So I wanted to do a video about setting up this VFD. I found in this project build the hardest thing for me to do was actually select which VFD to buy. Seems like there's a lot of choice out there and not a lot of great information. You also have to do a lot of learning to catch up with all the technology behind controlling three-phase motors. This is the one I went with. This is a WEG CFW300. This one's made in Brazil. I think probably the best advice I can give anyone who's doing a similar build and looking at a bunch of VFDs is to go and download the documentation first and read it. Pretty much you can be guaranteed that any VFD you're probably going to buy is not going to be made in America, and so it's going to have its documentation translated from some other language. It could have all the features in the world, but if you can't figure out how to configure it, then it's not that great. So anyway, I looked at the documentation for this and was pretty impressed. They're also on automationdirect.com. On their YouTube channel, they put a bunch of videos, tutorials about how to configure this thing and get it working. And so that's pretty awesome. I also felt like this one was a bridge product. It seemed like there are other ones in the line that are used in industrial applications, and then this particular one can take two kinds of input. This one can take single-phase AC as well as three-phase AC. So I thought that was good. I think most of us hobbyists are going to be running these in residences, so we're going to need that single-phase AC input. Also, last feature was I knew which spindle I was going to get, so my spindle was going to be 8.5 amps, and then this VFD is rated to output 10 amps, so it's got a little more padding. It's always a good idea to have that. This little extra, this is a COM module, so it's basically a little module that plugs in its USB. It's like $38 extra. So it's not that expensive, but what it allows you to do is connect the VFD to your computer and then manage all of the parameters through the free software that WEG makes for this line of drives. And that's, even if, it's a really powerful tool, and I'll show it to you in this video. So this is the electrical connector between the VFD and the spindle. This connection is really critical, and it's hard to actually do this well. This connector has a lot of thermal mass, so in order to solder the wires on there, you really need to get it hot, and that tends to basically shrink any heat shrink tubing you're using, and just makes things difficult. So there's a lot of potential for crossing connections in this connector. Basically, I got this connector finalized, everything nice and tight the way I wanted, and then I disconnected it at this end, so it was dangling in the air. And then I came over to the VFD and then disconnected. These are the cables that are actually going out to there. So I disconnected all three of these U, V, W. And then with a multimeter in continuity mode, I verified that there was no continuity between any of these three wires. And there was no continuity between any of these three and ground, and no continuity between any of these three and the shielding wire. So those are really critical. Basically, inside your VFD, there's these IGBTs are really sensitive to these kind of overcurrent situations, and some of them will claim to have circuitry to protect against that, but they don't always work. And so if you do have one of those connections, you're gonna regret it. So this is the WEG programming suite, version 2.5. So this is free software developed by WEG to support their line of variable frequency drives. This software is available on their site for free. You don't have to buy anything from them in order to try it out. I bought my drive from Automation Direct, and they actually happen to have a series of tutorials on YouTube on how to download, install, and configure this, and basically get it running and use it. And so I don't intend to replace that content here. I'll just try to focus on how I used it to configure my VFD and get it going. So hopefully that's useful. So anyway, you do not have to connect this to your VFD to try this out. When you set it up, you can actually specify which VFD you're interested in, and it'll download a little module that contains the parameters and things, so that you can at least poke around and see what the parameters are for the VFD you're interested in. But anyway, I did connect mine already, and I've created this profile called Build Bug VFD. And so we'll go into the parameters section. And so this is a tab. This tab shows you all the parameters on the VFD. And so if we scroll down, we'll see that mine has 959 parameters. That's quite a lot. Not all of these parameters are configurable by the user. Some just reflect internal states, but it's still really useful to see them all in one place. So each, they display here the parameter number, the description. This column offline is essentially the state of the parameter within this software, where it can save a file to the file system, and you can load it and version control it. And then the online column is referencing, this will be blank until you actually connect to your VFD, and then it'll provide what are the values on the VFD right now. And then minimum and maximum values for the parameter, and the factory default for that parameter. And then also a unit if it's applicable to that parameter. So that's really helpful. I think this is, even if you do not buy the optional COM module with that USB port, it's still really useful to have this data. I found it really helpful when I'm reading the documentation that I can come here and use it as a parameter reference. I can quickly look things up. Oftentimes in the documentation, one parameter will reference several others just by number, and you're like, oh my God, what does that mean again? And so it's a lot easier to use this than to look it up in a PDF or a quick reference card or whatever. So the other feature that's useful is that they break these parameters down. So this parameter is all of them in one big list, and then these are grouped by various topics. And so HMI is basically what WEG refers to as the human machine interface. So that's basically the front panel of the VFD. And so if you want it, these are the parameters that reference that. And so if you want to control or change things on the panel, here's where you'd come. And so here's motor control. That's the meat and potatoes of VFD configuration. So we'll start here. So this VFD supports two types of motor control. I guess I'll say I don't think I'm qualified to provide a good review of three-phase motor control. I think the topic's really quite deep. And I think I'll just leave it to the professionals. There's lots of good stuff on YouTube, and I think I'll try to link some stuff that I found useful. But I guess for the purpose of this conversation, V over F is voltage over frequency, and that's commonly referred to as scalar motor control. And that's what I would call the old school method of controlling three-phase motors. Basically, the default is it's a straight line. It's a linear curve of voltage over frequency, and then it also supports what's called quadratic, which is either a convex or a concave curve, which controls, I think, startup torque a little bit better. But this VVW is basically a proprietary, it's basically voltage vector WEG. And so that's WEG's proprietary name for vector motor control. And so I think I'll provide another link, which is a good summary of why you might want to consider or use vector motor control with your spindle. But in summary, it sounds like it's a much better way of controlling both the torque and the speed over the full range, but especially controlling torque at low RPMs. And so for a woodworking machine, maybe that's not super critical, but if you want to, let's say, mill some aluminum or something, you'll probably want to slow your spindle down, but yet maintain full torque. And so that might be useful to you. But anyway, that's my intent. I intend to configure this and use this vector motor control. It's also referred to as field-oriented control. And more specifically, in this case, it's called sensorless field-oriented control. And so in industry, they often put encoders on the rotors of these three-phase motors, and those encoders report back to the VFD where the rotor is in its rotation. And that is very useful to control the voltage, the frequency, or the current while controlling that motor. But in this case, the sensor is not available, and so it's called sensorless. And so I think that's it for the sort of summary of this, tool, using it in a disconnected manner. I will say I'd like to show, like, in this wizards folder, these are features that will require you to have that optional COM module and actually connect your VFD to this software. But under this main signals, this is basically the same as device not connected. Yeah, no problem. It's basically the same as a Mach 4, the real-time diagnostic window. So let's say you're having trouble, you've commanded your spindle on, but it doesn't come on. This is a great place to come to see what are the real-time status of my digital inputs, my digital outputs, or in this case, maybe the analog, the analog reference voltage, which controls the speed of the spindle. So what are those being reported as well as, it echoes here the status of the VFD. And so, as you can see, all of these have parameter numbers associated with them, so you could see them just using the front panel. But obviously, you're going to have to peck around quite a bit on that panel to get all of the information you can just see in this one window. And so, the parameters along with these wizards, in addition to the good documentation that this drive has, this is basically the documentation PDF. Basically, these are the things that convinced me to buy this particular VFD. So I think next we'll just connect the drive to this software and configure it and get it running. So here I have the controller turned on and I have the USB wire here connected. One of the first things I'm going to do is just to do a factory reset to make sure all the parameters are set to 60 hertz. There's basically two default settings for this VFD. One's 50 hertz and one's 60. And so I'm just going to load that. So if we go to P204, oops, that's the wrong way. Okay, P204. And then we set that to 5. So that'll perform a factory reset. So it reset all the parameters to the factory defaults for 60 hertz, basically North America. So that's kind of a good baseline to do before you get started. All right, so here we are back in the WEG programming suite, and essentially we have the USB wire connected to the VFD, and so now I'm just going to hit the connect device. So there's a little more in those tutorials from Automation Direct about setting that up correctly, but anyway, I'll leave it to them to describe that. But anyway, as you saw here, this online column got populated. And so basically it's connecting to the drive, as you can see by this green dot down here. So when communication is in process, it flashes. And so basically it's going down the list and basically populating how the drive is configured here in this UI. And so now you can see in the red, it's showing you a diff, basically. It's like it's highlighting all the differences. And so this offline, remember, is how I've configured it locally on my laptop or my desktop, really, and how it's differing from how the drive is configured. And so I just reset all the parameters on the drive to the factory defaults, and so you can see how it's diffing. And so It's a little clunky because I'm still in the list of all parameters, so it's sort of following my scroll and updating in real time. But if we go in and drill down and focus on a particular topic, say motor control common here, you'll see it gets a little more responsive. And so basically here we see that online the acceleration time, which is in seconds, was the default is 5 seconds, and I pumped it up to 20. I think decelerate was 30. So I'm just padding these. So these are basically in red are my configurations. These are things I've chosen to specify. And so in this case, the maximum output current I'm specifying is 8.5 amps for the drive. And I am actually going to specify the type of control as VVW, so voltage vector WEG, otherwise known as vector mode, vector control. So down in here, this is sort of most of the juicy bits. So we're stating that we want to use VVW as the control mode. These two are really sticking points for me. I have no idea what the rated efficiency of my spindle is. I'm sort of gonna just plug in 80 because that's the best guess I can derive. If you guys know a link to better specifications for these JCONG motors, I would love to see that. Basically, according to the documentation of this VFD, this motor rated efficiency and the power factor are very important for this vector control mode. And as you saw in the previous video, I measured directly stator resistance, and so I can put that in as 1.35. But these other two, I'm just guessing. It's a shotgun guess. I don't know. And so that's a bummer, but it is where we are. And so the motor's rated frequency is 400 hertz. The speed is 24,000. That's its maximum rotational speed, and the current is 8.5 amps at 220 volts. I'm sure there's a lot of other little control specific. So these are things that I've needed to configure to get my direction to work correctly. So I've basically told it the digital input 2 is forward run and digital input 3 is reverse, and then digital input 1 is run stop. And so basically those are the signals it will listen for running, as well as which direction to run in. And then I'm using the default, which is the analog speed reference of 0 to 10 volts. So basically the speed is coming from that PMDX 424 board. It's really its daughter board. And so the VFD creates a 10 volt signal. It goes out to the PMDX's daughter board and then is modulated from 0 to 10 volts. And so 0 means I want the spindle to go at 0% of its max rated speed, and at 10 volts I want it to go at 100. And so that's basically sort of the default setup, and that's exactly what I need in my setup. And so basically, as you can see here, what we can do is actually write these values out to the drive. And so you can write them all, or you can write them by one of these subsets. At whatever's in this screen will be what gets pushed up to the drive. And so here I'm actually going to take the parameters that are in this offline column and actually write them to the VFD. And so to do that, use these icons here. Here I'll just click on this and we'll write the parameters to the drive. So it takes time. It's got a little dialogue here. So anyway, once we've written those parameters, we can drill in and actually see. If we go to let's say the motor control, it will then refresh in the online column, and we'll see we no longer have any red. If we get more specific, let's go to VVW. So we'll see that now we have actually changed the drive's configuration. So now it matches what we have here locally on this PC. And so we've changed it to, we want to run variable voltage vector WEG, which is vector control, and we're a 3 horsepower motor, 24,000 RPM, 8.5 amps, all of that. So basically that is now the equivalent of me, you know, pecking on that front screen for about an hour, because that's how long it would take to enter all these, I'm sure. So that's good. As far as I know, I believe all of the, you can, like, for example, if you wanted to submit a, let's say, where is it? The 204 that we just submitted manually at the panel. Geez, 204. Oh, because I'm in the wrong place. Thank you. Thank you for telling me I'm an idiot. Okay, so basically, at the panel, we submitted a 204. We set that to actual 5, which was load 60 hertz, load the defaults, load all the parameter defaults for 60 hertz. And so you could actually set that here, and now we see it turns red because it's now different than the actual VFD. And so we could push this change and it will actually do the reset as well. And so I believe you have near total control of the VFD as if you were at the panel. I know of one exception to that, and that's in the motor control section. So this VVW, the vector control, there's a self-tuning parameter, and it's a 408. As far as I know, you can only submit this when you're at the panel. I guess we could try it. Want to try it? I don't know if I want to try it. So anyway, this runs a self-tuning procedure. As far as I can read from the documentation, this will actually try to measure that stator resistance as it's connected and come up with a number, and then use that number down here in the stator resistance column. But I'm not sure if that's the only thing it does. I'm going to run that self-tuning from the panel. So let's do that. All right, so here we are back at the panel. I want to go to P408. Oh. See, I don't know, man. I tell you, this panel is painful. So, anyway, P408, and we want to set this from 0, which is no, to 1, which is yes. And this is going to run a self-test on the spindle. And so what I think that's going to happen is that the spindles should not move, but it's going to send a small bit of current, DC, through the stators of the motor, essentially doing the same resistance test that we did in the other video. So let's cross our fingers. Saying auto. I heard kind of a high-pitched hum, and we're back to ready. So that's interesting. So let's go check out what the parameter changed to, if at all. All right, so back here in the WEG programming suite, let's go back to VVW section, and so we'll get a quick refresh. And so we see that our stator resistance was updated as I sort of expected. So basically, we changed this P408 from no to yes back at the panel, which ran the self-tuning, and then it updated this value for the stator resistance. And so this one, that was, it's kind of a wild card. So I measured it to be 1.35 ohms, and it's coming in at 0.79. And so, once again, I don't know which value to trust. I think I'm going to trust the self-tuning one. And maybe if we have troubles, then I'll come and revisit that. So I think I'll just accept that as it is. Yeah, it is curious how they do not provide a unit here in this particular UI, although they always referenced it in the documentation as ohms. So I will assume that it is ohms until something blows up. No. Yeah, so that's pretty much the main control parameters. I think I'm willing to try to spin it up and see how we go. Scary. All right, so back here I have the WEG programming suite running on the left and Mach 4 running on the right. And so we're going to try to turn on the spindle for the first time. So here's the diagnostic screen. We're actually connected, so you can see some kind of interesting stuff. You can actually see the DC link voltage. It's the voltage, basically the VFD converts AC to DC, and this is the voltage on the DC bus currently as we're sitting in the ready state. And there's a little bit of voltage leaking through my analog input for the speed control. And so basically when this comes on, I'm expecting digital input 1 and 2 to both come on. So basically the speed reference I think is on digital input 1 and oh no, it's on the analog input. So the speed reference is on the analog, and then digital input 1 is run spindle and digital input 2 is run forward. And so this is the G code we're going to submit, and hopefully we don't let the smoke out. No magic smoke. Here we go. I can hear it spooling up. I have a really conservative ramp, so it should take about 20 seconds to come to full speed there. I've commanded it to be 10,000 RPM. It sounds really good, which is good. And so I think that's going to be it for my first run. And I'm going to submit an M5, which is stop. And then we should ramp down. I think it's 30 seconds, I configured. So, ooh, man, it's a relief. Actually, kind of scary, because you know you do all this research, and you buy these products, and you just don't know if it's all going to work together until you press the button and either let the magic smoke out or it works. So that's actually a big relief. Cool. Thanks for watching.